This conference will now be recorded.
Yeah, in the last class, we stopped at this example where we were talking about this inferential statistics.
Yeah.
Okay, here we have the data wheat price. So I'm importing the libraries NumPy, Pandas, and Stats. And then this is our data. The state-wise, we have the wheat price, highest and per quarter median price, and lower price also. We have the data which is about of 2014. So I'm just now retrieving the dates. Okay, the considering the date and getting the month and year. So
Okay.
these two columns are added and then displaying the data. So these are the columns. What is the month and what is the year? Okay, in particular no state, what is the price?
Yes.
So like this, we have the data, and then we want to find the wheat price in California in the year 2014. So we are just retrieving the state. State is equals to California, and the year is 2014. So this is the condition, and then we are storing this data separately into the wheat California 2014,
Okay.
and then getting the mean of wheat price in 2014, and also the standard deviation. So the mean wheat price is this 245.89, and the standard deviation is 1.28.
Okay.
And then the question over here is, are these high quality wheat prices in January 2014 have the significance with January 2015?
Okay.
So this is our objective. So next I am retrieving the data for 2014 January and 15 January. So just
Okay.
applying the same condition for the same state, California, and then getting the mean price in for both the cases. So here you can see 248.44 and 243.60. So there is no much difference between these no two values. So
Yeah.
we can calculate the effective sizes. So that means January 2014 minus January 2015 mean price. So that is only the small difference, 4.84.
Okay.
So in this case, null hypothesis is, are these prices are not significantly different. So
Yeah.
mean prices are not significantly different. So that is true. But we want to prove this with a test which is called as t-test. Okay, this is the function t-test on the price. So the t-test value is this much. That is a probability value after finding the t-test is minus 6.29, and this exponent to the power 6 minus 68. So this is very low value. So this value is almost zero. That means the price difference is significant as per the interpretation of p-value. If p-value is less than critical value 0.0405, then we can say that there is a significance. So you can reject the null hypothesis.
Yeah.
So here null hypothesis has been rejected. And we can also calculate the chi-square test in order to find out the goodness fit for these quarters. So retrieving the data again for January 2014 and 15, and then the month is 1/1. Okay, the year is 2014 and 15, and then we are selecting these three values: high Q1, mid Q1, and low Q1. And you can apply chi-square test when more than two categories are there, when more than two values are there. So these are the three features. More than two we are considering.
Okay.
And then expected value, you can calculate that the expected is equals to so numpy array January 2014, applying the sum on the axis 0, that means on the row. Similarly, getting this expected and observed one, and now calculating the displaying the expected value and observed value. So you can see these three values for these three cases: high QN, mid QN, and low QN. So these are the three values. Now we are just performing this chi-square test. So stats.chi-square test, and then comparing this observed and expected. So the p-value is 0. Okay, p-value is 0. So in this case, so we can reject the null hypothesis. That means the January 2014-15 is different than the what we expected.
Okay.
So this is how you can perform these chi-square test, and t-test squares are very important to prove our hypothesis or to accept or reject our hypothesis. Okay, so
Yeah.
here we discussed about what is the inferential statistics, and then what are the important, what are the types of statistics, and then what are the measures.
Yeah.
And any questions?
I'm good. No question.
Okay. Then next we can move on to this deep learning. So we'll have a introduction part. What is deep learning? So we covered Python basics, Python libraries, and machine learning maximum. Okay, that means we discussed around 10 algorithms, and these algorithms are enough. Okay, now let's move on to after machine learning, we can move to the deep learning, and the prerequisite to the deep learning is the machine learning.
Okay.
So what is the background of deep learning? And today, the most of the important problems are solved by this deep learning. So this deep learning today is impacting everywhere, especially in healthcare, to transportation, and also manufacturing. And in these cases, you can apply the deep learning. That means simply to say that complex problems are only solved by using the deep learning. There is no other technique or mechanism to solve the complex problem.
Okay.
These problems like speech recognition, object recognition, machine translation, in these cases, you can use deep learning. And today, machines are becoming very intelligent, and they are defeating the humans. In 2015, what happened is the AlphaGo, machine actually defeated the Go player.
Okay.
And later on, this has been applied to different games, and these machines are proving much better than the humans.
Okay.
So that is why, because of this importance and to solve these complex problems, the companies like Google, Tesla, Uber, they have been now trying to develop these self-driving cars, okay, where this deep learning mechanism is applied. Example, if you know this is deep learning, this is a self-driving car, there is no driver, so the machine has to make clever decisions in terms of its operations, like slowing down, or stopping by itself, okay, taking the diversion, speeding up. So whatever the operation it has to perform, it has to make clever decisions. I'm saying clever decisions. That means predicting the activities with higher accuracy. So this is the Google trend for deep learning. So when the data is complex, so machine learning is not that much helpful to us. So we can use this deep learning for complex data, and this improvement has started in almost 2008, and then later on it has been increasing. So today deep learning is playing almost 90% of the problem can be solved by using the deep learning.
Okay.
So what is the prerequisite to the deep learning is machine learning. So you should be having the basics of machine learning and some statistical parts, like this. Also mathematics is important, Python, statistic, machine learning, and some mathematics. So these things are important. So we already covered this. So if you feel no shortage of knowledge on mathematics, you can refer this Khan Academy. You can find very good videos in YouTube. So you can refer this academy. It's good, very good. And what is deep learning there? Deep learning means you can have so many layers, so many deep layers, so that the accuracy is improved. And this deep learning works on the concept called as neural networks. where there is one input and we expect the output, and between the input and output you can have set of layers. With neural networks you can have maximum 3 layers, and then what these neural networks are not good in giving good accuracy and with speed. So this is a relation between these three fields, like of artificial intelligence is at the outermost. That means one the important component of this artificial intelligence is machine learning. That means you can bring intelligence to the program or to the machine by by machine learning only. So machine learning is the heart of artificial intelligence, and then specialized for part of machine learning is called as deep learning. Okay, so you can having a set of layers between the output and output, between input and output, so that your output prediction is done fast and with higher accuracy.
Yes.
So this is the relation between these deep learning, machine learning, and artificial intelligence. So you can think of the deep learning as the technique for where neural networks are applied, and you can have set of layers. For example, in 1980, these neural networks were ruled to give some good accuracy, but later on, no, they were not successful in processing the large amount of data and complex problem.
Okay.
So what happens with the machine learning is you need to create a model by using the training data, and then if you are not satisfied with the results, then you need to verify. That means you need to change some parameters so that the accuracy is improved. That means you need to verify the success of your model, and if it is proving good, then you can continue or you can stick with that model, or else you need to change the parameters or you need to change the algorithm so that you have a good model. Okay.
Yes.
This machine learning is no trial and error basis. You need to try changing the parameters, and if you get good accuracy, then you can stick with that. Otherwise, you need to modify your approach.
Yes.
So this is the drawback of machine learning. This figure shows that if the amount of data is increasing, then the performance of machine learning model downgrades. Okay. But in case of deep learning, even though the amount of data increases, the model performs well.
Okay.
So this is very important to know that deep learning is only good for, machine learning is only good for small data. And if you have large data and complex data, so you cannot use machine learning. So you need to go with deep learning.
Okay.
And so this computer vision is one of the important a research area today, because which deals with the images and recognizing the images, recognizing the objects from the images. So in these cases, the research has been going on, and so the things are improving. Actually, a couple of years before, we could not process the images. Even the larger companies like Facebook, Google, they suffered a lot in understanding the images. But today we can now handle these very hard diseases like cancer, brain tumors. So that is possible because of deep learning only.
Okay.
So this actually this Facebook has done. They develop a software, and they asked whether the two unfamiliar photos of the faces shown to the same person, then human being will got the accuracy as 97.53.
Okay.
And when the same task is given to the Facebook software, the software was correct for 97.25. So how much is difference between these two? Very
0.2.
less.
Yeah.
Yeah, it's very less. That means now the machines are becoming more intelligent than the humans. So that is
Yeah.
the technology today. So this deep learning is good in case of speech recognition. And now today we want to have the technology in our natural languages, isn't it? For example, some poor countries know they want to adapt the very good the faster technology, but they are poor in language. In that
Yeah.
case, if there is some good software applications, so which they can use that in their own language, in natural language, then it is good for them.
Okay.
You
Yeah.
know, Google is also trying to incorporate the different natural languages
Yeah.
like this. So Google is using deep learning, and no, it has managed the energy consumption and up to 40%. That means they reduce the energy of 40%. Actually,
Okay.
Google means that they have a huge data. Okay, if you
Yeah.
want to make the data available, then their database servers must be running.
Yes.
So the data centers
Yeah.
must be running. In that case, they consume a lot of power.
Yes.
Then actually they did a research, and then they applied deep learning. By applying deep learning, they cut their energy needs for up to 40%. That means they save some hundreds of billions of dollars in this case.
Yes.
So deep learning, what is deep learning is a neural network concept with several layers of nodes between the input and output. And this deep learning is the only one solution in case of processing the images, speech, and also in the text. So between the input and output, you can perform these activities like feature identification, and then processing those features in series of stages, like our brain do. Okay. For example, I want to give you a task. Let's say that I have shown you something, and then I asked, "What is that?" Isn't it?
Yes.
Let's say you answered something. Then I
Yes.
said wrong. Then I said wrong. Then what do you do? Yes, I said wrong. Then what do you do?
I'll think about it. Yeah.
Yeah, you think about it more. That means you think
Yeah.
about it deeply.
Yeah.
So our brain also has set of layers. So when I said it's wrong, then you can use your deep layers.
Yes.
So the same concept is now applied with this deep learning. So you can
Okay.
think about the features when you do recognition of some objects deeply.
Okay.
So what is the new idea with deep learning is that this is a neural network concept. You can see here set of inputs, and you have one output. Between the input and output, you can have one or two layers with neural networks, maximum three layers. So but with deep learning, the new idea is that you can have a set of layers between the input and output, many layers between the input and output, so that the accuracy is improved.
Okay.
And one more point to be noted is what we have done so far is when we build a model, so we try to get the value for x and y. Okay,
Yes. Yes.
we build a model dot fit of x comma y. What is x there?
X is the
What is
test value.
Yeah, x
Right.
is the
Right.
x has a set of features.
Yeah.
Okay, in training data, we can have set of features, and finally we can also have target variable.
Yeah.
Okay, so in y we can store our target variable, what is to be predicted, and in x we can store set of other variables on which
Yes.
y depends.
Yes.
But so that you are doing manually. Actually, you are determining what features should be there in x.
Yes.
Okay. So that is manually you are determining what are the values of x. But with deep learning, the features are extracted automatically.
Okay. Yes.
Okay, you don't need to specify the features.
Okay.
So that is a big advantage. Let's say what is the past trend is that when I show you the when I show the some when I give the task of identifying the face, okay, face,
Yeah.
then the past approach is that just by looking at the eyes and nose and mouth and some two to three features from the face, so the software can identify the person, isn't it?
Yes.
And
Yes.
he can label who is the person. But today, with deep learning, there's no need to specify these things. The eyes and nose, some important features. So if you just give the image of face, to the model. So model automatically extract each and every part of the part from the face,
Yes.
and it gives the higher accuracy.
Yeah.
So this is the figure you need to keep in mind. So between the input and output, you can have set of layers. And here I just want to show you the drawback of this neural network. So this is how the neural network works, and these are the inputs: minus 0.06, minus 2.5, and minus the 1.4. And every input is associated with the weights like W1, W2, W3. And these weights are multiplied with the input. And then if you give these two as input to the activation function, here f of x is the activation function, which gives us the output.
Okay.
Which gives
Yeah.
us output, and this is the formula for that: f of x is equals to 1 by 1 plus e to the power minus x. So this is the sinusoidal form,
Okay.
the S shape. If you get
Yeah.
the value as, for example, 0.6, you get the value of 0.6, then you can interpret that value as 1.
Okay.
That means positive class. And if you
Yeah.
get the value as less than 0.5, then you can interpret that as 0.
Oh, okay.
Okay. So this is what this activation function gives the output. So normally the neural network works in this manner. And then, for example, I gave these values for these weights, and then I got the value as 21.34. Then I can
Okay.
just interpret that into 1. So this is a positive value, so I can convert that into the 1, like this. So here let's take this data. It's a data set we have here, and then I just want to understand what is the drawback of these neural networks. So how these neural networks works is I have to initialize these values. I'm taking the first row, whose values are 1.4, 2.7, and 1.9. So I'm considering these three are the input, and then we can multiply this input with some weights, and let us assume that you got the output as 0.8. Okay.
Yes.
But what is the expected class? You can see there in
0.
the training data, expected class is 0.
0.
That
Yeah.
means what is the error here?
0.8. Yeah, almost.
0.8 is the error. In
Yes.
that case, what I have to do is I have to adjust the weights.
Okay.
I have to adjust the weight so that I try to get the output class value as 0.
Yes.
Okay, I need to adjust the weights so that I get the output as 0. And now
Okay.
in this case, you can see if these are my values: 6.4, 2.8, and 1.7. And then let's assume that I have got the output as 0.9. So I'm expecting the output class as 1. So how much is the error?
0.1.
Yeah, 0.1. That is minus 0.1,
Yes.
isn't it? So if you add
Yes.
this 0.1, then it will become 1. So it's a negative error. So
Yes.
minus 0.1. So in this case, again, I have to do the modification of weights.
Yes.
Okay. So like this now, if my data is big, then I need to do the modification. That means some millions or thousands of time I need to do the changes. So it's a
Okay.
very time-consuming process.
Okay.
Okay, it's a
Yeah.
time-consuming process, and we need efficient algorithms which can adjust the weights.
Okay.
And if your algorithms which are modifying these weights are not good, then output is also not good.
Yes.
Okay, it
Yes.
depends on the weight adjustment algorithms. With neural networks, the weight learning algorithms are dumb. Okay, they are
Okay.
not good. Then so you need to do the adjustments and adjustments. So it is a very time consuming process, and you need to have very good encoders, and also very good weight adjustment algorithms. So this is a drawback of neural networks. Okay,
Yeah. What is
and
NNN? Total name?
NN stands for NN stands for neural network.
Okay.
That is short form.
Yes.
Okay. Yeah, please, if you don't understand, you can ask me. Actually, if you are the computers, if you are not know these things background in BTech or MTech level, actually we just know studied these about the neural networks. Okay, I thought you just know it. Okay, if you don't know this like this, you just ask me. Okay,
Okay.
okay, NN means neural network.
Okay.
It's a short form. Like
Okay.
AI, AI means artificial intelligence.
Yeah.
Okay,
Yeah.
I like that.
Yes.
So the new approach for this for the complex problem is deep learning. So between the input and output, you can have set of layers to produce
Okay.
the output. So this is a new idea. So what happens with the deep learning is, so you can do the training. So this input and this is the one intermediate layer. So this
Okay.
produces some output, and that output is given as input to the next layer.
Okay.
Again, that output is given as input to the next layer.
Okay.
Okay, again
Yes.
input, so finally you produce the output.
Okay.
How this neural network works. But
Yes.
here we need some encoders and decoders.
Yes.
Okay, so that means here you are giving input and then it produces some output, and then that output is given as input to the next layer. So actually this is done by the auto encoders. And this
Yes.
what these autoencoders will do is they try to extract the features in each layer.
Yes.
That is at the input side, and at the output side again you need to convert that. Okay,
Yeah.
like this is the input and then you encode the features, and finally at the output you decode the features.
Yes.
Okay, so this is the concept of deep learning, and these things are automatically done, so we don't need to do any changes, any configurations in specifying what features are important and all. So this is the between the input and output you can have so many layers as you want. If you are not satisfied with the output, then you can increase the number of layers between the input and output. Okay,
Yeah.
so finally last layer gives the output. So this is a new idea. You can have input layer, you can have output layer. Between the input and output you can have set of layers. So what are the advantages of deep learning today? The most important applications. So here I'm mentioning some important applications. The first one is internet and cloud. In internet on cloud, as I said before, deep learning is good for image classification, object recognition, speech recognition, okay, and also in language translation, language processing, sentiment analysis, building recommendation systems. So in this case, deep learning, playing an important role in internet and cloud. In media, in medicine and biology, so as I said before, today we are able to detect these cancer type of diseases, okay, cancer cell detection, also diabetic grading, and identifying the drugs, okay, drug discovery.
Okay.
So in this case, deep learning helps, and also in media and entertainment, when you have lots of videos, then we need to group the videos, and then we give them some labeling. So
Yeah.
this is called as video captioning, and also searching the videos with some labels. In
Okay.
this case, deep learning is used, and some real-time translation of outputs. In this case, you can do this deep learning. Also in security and defense, in face detection, the deep learning is used. Nowadays, it has become a very smarter application.
Yeah.
No, in India, so many important this what's airports.
Yeah.
So they have been adapting this face detection software.
Yes.
So it reduces the time actually. So once you just appear in front of the camera, so that just get your details, and the processing is done immediately, and you can be move forward. So like this. So in face detection,
Yeah.
and that is a automatic face detection with higher accuracy.
Okay.
And in video surveillance, satellite images, for example, satellites produce so many images. isn't it? We have been launching the satellites. So if they produce some huge amount of images, then what is the use if you don't process them?
Yeah.
So in images understanding and autonomous missions, so you can use deep learning in pedestrian detection, lane tracking, recognizing the traffic sign, predicting the traffic sign a couple of minutes before. In these cases, deep learning play an important role. So these are the benefits of deep learning. Robust means no need to design the features ahead of the time. As I discussed said before, no need to determine the values for X. So these are automatically done.
Okay.
And also robustness to the changes in the data. Okay, if the data is changed, then the feature also automatically change. That means, let's say you build a automatic model. You have a model, and you build a model with some 10,000 images. Okay,
Okay.
and later on, a few images added to the training data.
Okay.
It means that the accuracy, should also be. That means your model should also consider the new data.
Yes.
And generalizable means it's not that you build a model for some specific task. Okay, and
Yeah.
then you can't use that for some other task. Okay, so once
Yes.
you build a model, then that can be used for different applications and
Yes.
also different data types.
Yes.
And scalability means performance improves with more data.
Yeah.
Even if we increase the data, then the performance also increases, not decrease like machine learning.
Okay.
Then what are the open source softwares we have for deep learning? So these are some important software applications. This deep learning for J. If you are a Java programmer, then you can use this deep learning for J.
Okay.
In the short form, it is known as DL4J, deep learning
Okay.
for Java. And this Theano is the one API,
Okay.
and Torque, TensorFlow, Cafe. So this TensorFlow is a very popular deep learning framework. And
Okay.
also this Cafe. And nowadays there is also the one of the tool which runs on top of this TensorFlow, that is a Keras, Keras. So Keras,
Okay.
this TensorFlow is a little bit low level, and the Keras
Okay.
runs on top of TensorFlow, so that the coding is reduced, complexity is reduced. So this
Okay.
deep learning 4J is JVM based, Java Virtual Machine based, and it's distributed. You can integrate this deep learning 4J with Hadoop and Spark also. And Theano
Okay.
is now very popular in academia, and it's low level.
Okay.
Low level means there is much complexity in writing the programs, and it is also interfaced with
What is
sorry.
academia? What is academia?
Academia means academia means, for example, this the problems are related to this education and learning.
Oh, okay. Okay.
Okay?
Okay. Yeah.
Academics means what? That one
Yeah.
only,
Okay.
no? Yeah, it's a
Yes.
plural. Academia is a
Okay.
plural.
Okay.
So it is interface with Python and NumPy, and this Stark is also the API, but you need to learn this language, Lua. Lua is the one
Okay.
language, and it has been
Okay.
used with this Facebook and Twitter, and it has some pre-trained models which can use,
Okay.
which you can use. And TensorFlow is written by Google, the successor to the Theano.
Okay.
And then you can interface this TensorFlow with Python and Python libraries like NumPy, Pandas.
Okay.
But no, it's a little bit slower in terms of some complex problem. But these days it's not an issue on Tensor. On top of TensorFlow, there is a Keras. And Cafe is one tool which is not for general purpose, but it focuses on machine vision problems, machine related problems. And it
Okay.
is implemented in C++. So you should be knowing the C++. And this C++ is more low level. C++
Yeah.
are more low level. So automatically, which gives you the fastness.
Okay. Yeah.
And you can And this cafe is extensible and it has a Python interface. So these are the some popular, or deep learning frameworks. But today, we are living in very competitive world, and every company wants to have their own application, own framework. Okay.
Yeah.
Some commercial type of companies also producing this different types of applications. Okay.
Okay. Okay.
This Anaconda, we are because we
Yeah.
are using it, isn't
Yeah.
it?
Yeah.
So nowadays, this Google also built the same software.
Okay.
So that is a Google Colab. Have you heard about it?
No.
No, I'll just show it here. Simply, you can type Google Colab.
Okay.
It's on Google Colab, and then click on this, and then it will take you to the online platform. Here, no, this is the Google collaboration, and here you can create a new Python notebook.
Oh, okay.
Okay. And what is the benefit is you can run your application. That means you can run your code on Google Cloud.
Okay.
And one more advantage is nothing to install. Every library, is already installed. You
Yeah.
can
Okay.
simply import. For
Okay.
example, you can import anything. I'm importing, let's say TensorFlow
Okay.
as TF, and then TF dot. I'm checking the version. And now it's processing, and this is the version 1.14.0. This is the version. So I didn't install any software here, so you can just import any library. Nothing required to install it. Okay,
Yeah. Okay.
because there's all these different types of libraries, makes the system complex, and compatibility issues will come. So in order to avoid this, you can use this type of this technology. But no, well, if you create your IPython notebook, then that is stored on the Google Drive.
Okay. Yeah.
Yes, and they are stored on the Google Drive, and you can see here how much RAM is used.
Okay.
And they give the maximum RAM is up to 12.72 GB.
Okay.
And I think I'm displaying the
Okay.
RAM is 12.72 GB, and hard disk is 48.97 GB.
Okay.
Yeah, so this is the good platform. So like this, people, companies just copy from others and they try to do it.
Okay.
So these are some important frameworks. So we are going to use this TensorFlow, Keras, and we are going to use this OpenCV, computer vision,
Okay.
and we do some deep learning models. And one more thing is how to set up your machine. Actually, these images, they works with this GPU.
Yes.
What is GPU?
Global. That's.
No,
I don't know.
graphical processing unit.
Okay.
We have CPUs,
Yes.
central processing units also. So
Yeah.
these GPUs, are required for graphics.
Okay.
Even our laptops also have some inbuilt, a
Yeah.
GPU,
Yeah.
a 4 GB graphics card. Graphics card is there, no? That is
Yeah.
nothing but GPU.
Okay.
So in order to work with these images and all, so better you should have GPU installed. And this you can also install the software which GPU based software. For example,
Okay.
this TensorFlow comes in two ways. You can install TensorFlow GPU based and also CPU based.
Okay.
Yeah.
Okay.
So this is the setup, and there are so many online courses for deep learning also. So for example, this is the Coursera course, which is this person, this Andrew Ng, he's a very famous person on deep learning.
Okay.
You can find his resources, and also in Google, in YouTube videos, you can find the videos.
Okay.
And these are some important resources I'm mentioning to get the knowledge on the basics and deep learning and also machine learning. So these are the important one. This is one of the very basic book. If you just browse this URL, you will get the PDF copy of the book. Deep
Okay.
learning book is
Oh,
there.
free,
You can also
free book. Okay.
yeah, it's a free.
Okay. Okay.
Yeah, you can get that. If you want, I
Okay.
can show you. Yeah, you can see this is the MIT Press book. You can also get some resources on this. And yeah, click on this. You can see this the front matter. Earlier, actually, there was a complete textbook. We used to get the complete textbook. Okay, anyhow, I can send you this textbook.
Okay.
So these are some important resources about deep learning.
Okay.
And you can also have this video series on YouTube, Deep Learning Simplified. It's a good video series. You can go through that. So this is just the introduction part, and in the next class, what we can do is we can install these TensorFlow and Keras, and then we can learn the basics of these tools, and then we can go for building our deep learning models.
Okay.
Okay.
Yeah.
Any questions?
Yeah. Can you send me that book you mentioned, deep learning?
Okay, I'll send you.
Okay.
I'll share. I think. Okay. Have I shared some books through my Google Drive? No.
Google Drive.
I have. I think I have shared some books with you. Am I right?
I didn't check the Google Drive. Let me check.
No. Have I shared some textbooks with you?
No, I don't know actually.
Okay. I'll share now. I'll share some set of books. You can just download.
Okay.
Okay. Then we'll meet you tomorrow.
Yeah. Yeah. I don't see anything in my Google Drive.